Okay, let me redo this part since it wasn't recorded. So I'm going to calculate and then you figure out whether you have done it correctly or not. So first of all, you get the predicted values and actual values. Here also you'll have the predicted values and actual values. Let's go to the first row. The value here is 5. 5 is less than or equal to 5. So the predicted value would be yes. Actual value also is yes. Then let's go to the second row. The value is 1, which is less than or equal to 5. So the predicted value will be yes. And the actual value also says yes. Then we go to the third row wherein we have 5. Less than or equal to 5 would be yes. Actual value is also yes. Then let's go to the fourth row. We have 5. Is 5 less than or equal to 5? Yes. So the predicted value will be yes. Actual value is no. There is a mismatch. Now let's go to the next row where the value is 10. 10 is greater than 5. For greater than 5, the predicted value would be no. But what does your actual value say? That also says no. There is a match. Now let us calculate entropy towards the left and entropy towards the right. Left side is this. Okay. So less than or equal to 5. Okay, that's your left side. So less than or equal to 5, you'll have 1, 2, 3, 4, all these 4 values. Okay. And then what would be the, how many y do we have here? 3 out of 4. And how many no do we have? 1 out of 4. So here, going by this entropy formula, since you have two classes, yes and no, we write this as minus summation of I equal to 1 to 2, probability of xi into log of probability of xi base 2. When you substitute I equal to 1, you get minus probability of x1 into log of probability of x1 base 2. Again, minus. When you substitute I equal to 2, you get probability of x2 into log of probability of x2 base 2. Probability of x1 is 3 by 4. So you get minus 3 by 4 into log of 3 by 4 base 2 minus x2 is 1 by 4 into log of 1 by 4 base 2. How much would you get when you solve this? Let us solve this. It would become minus 3 by 4 into log of 3 by 4 base 2 minus 1 by 4 into log of 1 by 4 base 2. And then you get how much? 0.81128. This is going to be a probability towards the left. Okay, let me write it as 0.81128. Now let's calculate probability towards the right side. So the left side part is done. Let's calculate the probability towards the right side. On the right side, it is only greater than 5. Greater than 5, how many do we have here? Greater than 5, you have only one entry because we are doing it for price. Price greater than 5, how many do we have? Only single entry. So take this one. So what will be probability of y? How many y do we have here? 0. 0 out of 1. And how many no do we have? 1 out of 1. 1 by 1 is 1, 0 by 1 is 0. So how do you write it as? Minus 0 into log of 0 base 2 minus, you have 1. 1 into log of 1 base 2. 0 into anything is 0 minus 1 into log of 1 is 0. So overall you get 0. Correct? So entropy towards the right side is 0. Now what are we expected to do? We need to combine left and right side. In order to combine these two to get entropy after, On left side, how many do we have? 4 out of 5 entries. So 4 out of overall 5. So I write it as 4 by 5 into entropy towards the left. Entropy towards the left is 0.81128 less. On the right side, how many do we have? Only one entry, 1 out of 5. So 1 by 5 into entropy towards the right side was 0. So 1 by 5 into 0 is 0. What will be 4 by 5 into this? Let's calculate. 4 by 5 into 0.81128. When you solve it, how much did we get? This is what? Entropy after. Okay. So we got entropy after as 0.64902. And what is entropy before? 0.97095. When you subtract these two, you get information gain for price. So let me do that. This value minus, not this. Sorry. You should get 0.32193. Okay, this will be the entropy after. Now, after this, we'll run the code and then we will jump into the other discussions pertaining to the other ensemble techniques. Before that, let me look at 2 questions, 3 questions. Okay. Shouldn't we convert continuous features to discrete? Yeah, you have to convert them. Or leave it to decision tree algorithm and that would automatically convert you. Point number 1. Okay. But here we are not doing it. Okay, that's fine. I'm leaving it to the algorithm to convert. But I'm treating these as objects. Count, categorical count it. Okay, Ali says, for every entropy before and after, we will get 0 only. Why will we get here? We didn't get, right? We got a different value. Hope that answers your question. Now, yeah, our friend had a question. Yes, please. Predicted value will be, condition will be. Condition is less than or equal to 5 and condition is greater than 5. That's a rule. Okay. Yeah. Based on that prediction, you got the value as no. I don't know to what extent I can go back, but let's see. That's it, I think. Okay. Tell me, go ahead. So there is a specific column called as price, which is a feature in which we are having a classification rule, which is less than or equal to 5, greater than 5. For less than or equal to 5, I'm saying yes, it'll be useful for play. Greater than 5, I'm saying no. What is your question? Do you have any doubts here in this rule? Yeah, in this rule only. Yeah. In this rule, do you have any doubts? That's the question that I'm asking. In this rule, do you have any questions? No, fine. Yeah, next. Okay, in serial number 4. I have 5, which is less than or equal to 5. So what will be the predicted value according to this rule? Yes, wonderful. What is the actual value? This is actual value given to you by a customer. Yeah, obviously. No, why will you take this? This is the prediction. Actual is given in the data, right? Whatever is given to you by the customer is actual value. No problem. Clear, right? Okay. Hold on, we'll get there. Venkatesh, we'll get there. Hold on. Okay, first, let's complete this, okay? What do you mean by greediness, Venkatesh? Okay, let me unmute Venkatesh because Venkatesh feels that he asked me this question twice and again he might be offended. So Venkatesh,
No, no, sir.
yeah,
I
yeah,
was just curious.
yeah, yeah.
That's
So
all.
what do you mean by greedy? Are you a greedy person, Venkatesh?
So
If I give you
greediness.
two job offers, if I give you two
Uh-huh.
job offers, in one job offer, I'll say that I'll pay you 10 lakhs per month. And in
Hmm.
another job, I'll pay you 2 lakhs per month. Which one would you choose?
10 lakhs.
So you're a greedy person, right? On similar lines, why is
Uh,
decision tree called as greedy algorithm? Because when it does that split, is it
mhm.
choosing that variable which has the least information or is it choosing that variable which has the highest information?
Highest information.
Oh, you're going with highest information. That means you're greedy. Like salary, I go with the highest salary, right,
Mm.
Venkatesh?
Yeah, yeah.
That's the logic behind naming this as greedy algorithm. Simple. There's
Okay,
no
okay.
extraordinary reasoning here, right? Simple. Lazy. Lazy algorithm is KNN, K nearest neighbor. Why is it called as lazy algorithm? Because it's like students only. When I say tomorrow we have, or if I say that exam will be on 31st August, when do you end up studying? On 30th or on 31st morning.
Yeah.
KNN algorithm is also like that. When you give a new entry and say predict,
Hmm.
KNN will then start calculating the distance between that new entry to all the data points.
Okay, okay.
And then it will give you the result. So it will not already calculate and keep it, in the system because that provision is not there in KNN. Only when a new entry is given, new inputs are given, it will take those new inputs, it will calculate the distance of that new record or new set
Mm.
of inputs to each and every data point that you have to find the distance,
Right.
right? And then to whichever it is closest, it will assign that particular class. That is
Okay.
the reason why it is called as a lazy algorithm because it will do only at the last minute.
Right. Yeah. Thanks, sir. Thanks.
Yeah, yeah. Oh yeah, it will recalculate. Now, not just different k value. Say you trained your model, you kept it with you, job done. Now, if I give a new entry, what it will do is with that new entry, it will calculate the distance. If you have 1,000 training points and one new entry, it will calculate the distance between this new entry to all the 1,000. And then if you say k equal to 5, it will choose only the 5 nearest distances. And then for those 5, it will look at what are the classes. And the majority is what it's going to assign. When you say k equal to 7, out of all those, it will pick the 7, top 7. But when will it do that calculation? When you give a new record and say, tell me whether this new record belongs to A or B. Then it will do the calculation. K value is only used to choose from those. Okay, probably when we talk about KNN tomorrow, if I'm not mistaken, then we'll get it.
This problem, all the balls are in the same.
Hmm.
It's five balls are different colors. We can calculate.
Hmm?
We can calculate.
I didn't get you. Come again. Sorry.
In this problem,
Hmm.
all the balls are the same.
So first talk about this one. All the balls are in
Same.
red color. So
Different colors.
talk about only this. One after another. So we have ball color. And what are the two classes that you have? Yes and a no. Tell me. If it is red color, should be yes or a no? Why yes? We also have no right for it. Either it is red color or not red color. That is what you'll have. I got your question, but first let's solve this. Now you go ahead with the first entry. Is it red? Red is this side. So predicted value will be, actual value is also second entry. Is it red color? Predicted value will say yes. Actual value will say yes. Is this third entry red color? Yes. So the predicted value will be yes. Actual value is also yes. Is this red color? Predicted value will be, actual value is this red color? So predicted value is yes, actual value is no. For it is not even going into this, not even needed. So here you calculate your entropy after. Okay, entropy after means you choose everything now. Once again, you choose everything. When you choose everything for entropy after, because there's no left and right. So you choose everything. When you choose everything for probability of x1, which is yes, how many yes do we have? 3 out of 5. P of x2 will be no. How many no do we have? 2 out of 5. When you solve it, do you know what you'll get? You'll get the value exactly similar to entropy before. And what is information gain? Entropy before minus entropy after. And entropy before minus entropy after, what would you get? So do we have any information in this? No. Now tag it back to the discussion that we had in the very beginning of the training, wherein we spoke about exactly in data cleansing, we discussed about something called as zero variance or near zero variance features. What did I say at that point of time? If you have a variable wherein every value, if it is the same, you just remove it. You need not have it in your training. Oh yeah, you remove it. That's it. You need not even do all these things. I have a variable, every ball color is the same, just delete it. Now going back to your question. Our friend is saying that, no, this part I understand, but what if we have blue color and what if we have black color? Now we have 3 classes here and a ball color. Now I have yes and no is what I need to classify, but then I have what? Red, blue and black. So we have red, blue. For 2, you told us how to solve it, but what if I have 3? Then you can say red, blue and black. One rule. Then blue, red, black. Again, solve it like this. And then you'll have black, red and blue. So you have 3 different conditions. Okay, same yes and a no. Yes and no will be the same. Okay, yes and no will be the same. If it is red, yes. If it is not red, that means if it is blue or black, it will be no. For this, you calculate the entropy. Then calculate the entropy using this rule. Blue means yes, red and black means no. Calculate the entropy. Then black means yes, red or blue means no. Calculate the entropy. Whichever gives you the least entropy, least error, take that as a rule and proceed further with your calculation, entropy after calculation. Making sense? Okay. Nothing like that. No, there is nothing like that. Are those classes going to give you the right classifications or not? That is more important. That means, would it give you the right classifications here? That's important. The number of classes that you have in the variable doesn't matter. How are those rules related to this? Yeah, entropy will be, information gain will be high. Yes, yes. That's the same formula which is given here. Total number of classes. We have done that, right? 3 by 5, 2 by 5, that is this. Into whatever is the information that you get. Then when you subtract both of these, that is entropy or expected information, before versus after, you get the information gain. Okay. If you take this example, for that example also, the calculation is just given. You can look at that. Same thing, but 14 records. Okay. So you get all this information gain, and then which node would you choose as a root node? The one which has the highest information. And which one has the highest information? Age. So it chooses age. Okay.